Hello friends, this is Bright here. Through this video, we are going to see the pointer implementation concept in one-dimensional array. Here we have an integer array with three elements 10, 20, 30. Since the memory allocation for array is contiguous, we can see that immediately after 10, 20 is kept. Then immediately 30. Next to that 40. And here I mentioned the byte address. Just for simplicity, I represent it by a simple integer 101, 102, 103, 104. As we know that each integer needs 4 bytes of memory. The next integer it needs 4 bytes. Since each byte has a unique address, here you can see that the 10 starting byte address 101, it is ending with 104. And since it is contiguous, the next data starting address will be immediately after that. That is after 104, 105. Then 106, 107, 108. And next 109 is the starting byte address for 30. Like that 113 is the starting byte address of 40. And we know how to display every element. We can use a of 0. The 0 is the index or position. It gives the first element 10 and it gives 20. In this slide, I am going to show something interesting. We know that a of 0, it gives 10. And how about this statement? In the place of a, 0 is written. In the place of 0, a is written. Does it give any trouble? Answer is no. It gives the same output 10. We are going to see how it is possible. Let me show the computation behind it. Now, look at this slide. The first element we accessed like this, a of 0. And it gives 10. But you should know one thing, that whenever we access an array element, there is an internal pointer implementation. That is what I am going to show that. For any array accessing, let us say that a of n, it will be converted into an expression like this, star of a plus n. Let us see one case, a of 0. And as per this equation, we can substitute the values star a plus 0 star. What is the meaning of a? A means the base address of this array, or we can say the starting address of this array. The starting address of the array is 101. So we call it as base address. So whenever we write array name alone, its meaning is the starting array address. So 101 plus 0. Now let us add the values. 101 plus 0, 101. Now we can read it as value at the address 101. The value at the starting byte address 101, that is our 10. Now let us see about 0 of a. That is what we are going to prove it. How a of 0 and 0 of a are same. Again substitute the values star of 0 plus a. star of 0 plus A. A means the starting address of array, that is 101 star of 0 plus 101, it is 101, and value at 101, that is 10. Hope that you understood. A of 0 is equal to 0 of A. Now let us see about A of 1, that is star of A plus 1. Now A is 101 starting array address plus 1. Star of, now 101 plus 1, normally it gives 102, but here it will not be added directly. We know that this is an integer array. Each element is an integer. Each element takes 4 bytes. So when we add some address value with 1, this 1 will be scaled by the size of integer. If it is a double array, this 1 will be scaled by 8. If it is of character array, since it takes only 1 bytes, it will be scaled by 1 only. If it is of float, 1 into 4. If it is of double, 1 into 8. So star of 101 plus 4, that is 105. And we can see that the value at 105, the starting byte address of 20. So we will get 20. 105 is the starting byte address of 20. So the value at 105, 20. Similarly, A of 2. A of 2 means 101 plus 2 into 4. Let us see that computation also. A of 2. The value at A plus 2. The value at A means array base address, that is 101 plus 2. The value at 101 plus this 2 will be scaled by 4. The value at 101 plus 8 will get 109, and we can see from this diagram the value at 109. For 30, starting byte address is 109. So we will get the value at 109 is 30. So this is the internal pointer implementation of a one-dimensional array. Let me show a simple code. So let me create that array. Int a equal to 10, 20, 30, and I am going to use a for loop to display it. Int I is equal to 0, or no need to initialize it, we will initialize it in for loop. For I is equal to 0, I less than, we have 3 elements, 0, 1, 2, I plus plus, we can write printf %d /n for new line. Normally we display the array like this. Now according to the pointer implementation, If it is of a of n, we can convert it into star of a plus n. So a of I can be converted into star of a plus I. Star of a plus I. Now let us examine. We can see that 10, 20. Okay, here I put the condition as 2. Make it as 3. We'll get all the output 10, 20, 30. We can see that run finished, exit value 0. So it is a successful exit. That's all about the pointer implementation in one-dimensional array. Thank you for watching.